Yeah. So we were discussing about Fibonacci, series, right? Fibonacci series starts with 0, 1. Okay, starts with 0, 1, and the subsequent elements in the Fibonacci series is the sum of its two predecessors, as I said, right? Now we'll try to demonstrate here. We'll try to implement it with the help of recursion. Fine. So let us, try to write the function. Yeah. Fibonacci series. Okay, so let us write the recursive function for Fibonacci here. It is returning an integer value. Fibonacci taking, let us say, integer or as an argument. So here, if n equal to 0, for n equal to 0, what it has to return? It has to return 0 only. Yes or no? Starts with 0 and 1. If n equal to 1, it has to return 1. Okay, yes or no? If none of this condition is true, then what it has to return? It has to return the Fibonacci of n minus 1, its predecessors, right? Some of its predecessors, two predecessors will be the result. It starts with 0 and 1. The subsequent element, as I said, is the sum of its predecessors, two predecessors. So Fibonacci of n minus 1 plus Fibonacci of n minus 2. Yes or no? So now this is the Fibonacci recursive function. We'll write the main program, main function in order to implement the same. To generate the series of about n elements, we will take n to be read from the user first. We will be reading the n value here. Enter n value. Scanf. Reading n value first. Then, with the help of a for loop here, we are trying to call that particular Fibonacci recursive function to generate all the values I less than n, I less less. Okay, we need to print all that values here with a gap. So I'm taking an offset of 4. Then here I'm calling that Fibonacci function, right? By passing this I as an argument. Okay. So now what happens when I value is 0, I value is 0 going to be passed here, which is going to be returned as 0 itself. When it is 1, 1 is going to be returned. So 0, 1 will be printed. Then next, when I value becomes 2, what happens? When it goes here, these 2 are false. So that comes here, then n minus 1. Fibonacci of 0. Fibonacci of 0 is 0, which is being maintained part of the stack, and Fibonacci of 1 is nothing but what? 1, right? So that's going to be added and will be returned here, right? So when I value is 3, what happens? These 2 are false. It comes here. Fibonacci of n minus 1 means Fibonacci of 2, which is already generated before. It's nothing but, 1. And then, sorry, 2. And then Fibonacci of 3, when we are finding out Fibonacci of 2 is going to be 1 plus 2, 3. And then this is going to be what? See, 0, 1. These all the values are going to be maintained in the stack here first. Okay? It maintains. What happens here, you can see when you are calling the Fibonacci function for all such I values starting with 0, right? For 0 when called, what happens? Fibonacci of 0, it returns 0. So Fibonacci of 0 is nothing but 0, right? So 0 is printed. Then when I value is 1, Fibonacci of 1, for Fibonacci of 1, what happens? Here you have 1 to be printed. So 1 is going to be printed, right? Then next what happens when I value is, you know, 2, when I value is 2, Fibonacci of 2, for Fibonacci of 2 what happens? These two are false, it comes here. Fibonacci of 2 minus 1 is nothing but 1. Fibonacci of 1 is nothing but what? 1, right? Plus, and then Fibonacci of 0 is going to be 0. So 0 plus 1 is going to be 1. It will be printed. This is Fib of 2, right? This is Fib of 1. And this is Fib of 0, right? And for when I value is 3, what happens for 3 when the same function is being called here? These two are false, it comes here. Fibonacci of 2 and Fibonacci of 1 will be added. 2 and 1 is nothing, 1 plus 1 is nothing but 2. So Fib of 3 is nothing but what? 2. And what will be Fib of 4? Fib of 4 is going to be 2 plus 1, 3. Like that, it generates this series. How long? Until n minus 1. Okay. Let us try to demonstrate and see the result of the same. Okay. With the help of online compiler here. Okay. Let us create. Have you saved it? Save it as GCD. Recursion, recursive GCD, right? Dot C. Then create another project here. First, let us write the function here. Before writing the function, you're giving one comment line to specify what is that you're going to do here, right? To implement, what is that you're going to implement or to generate, I think, right? To generate Fibonacci series using recursion here. You can do it with the help of iteration that I have shown you before, the help of do statement or for or while statement, right? Now here int Fibonacci is our function taking, you know, one argument that is n here. If this n value is 0, you are returning what? 0 itself, right? Returning 0 itself. If n value is 1, what is that you're going to return? You're going to return 1 only, right? But if it is neither 0 nor 1, then you are going to add the two predecessors of this series, right? N minus 1 plus n minus 2, right? Minus 2, okay? So these two, n minus 1 and minus 2 are going to be its two predecessors which are going to be added. Fine. So here we'll try to implement the same. Now in the main function, we are trying to generate here the Fibonacci series, okay? How long we want to generate? Enter the limit. Enter the limit to generate Fib series. Okay. Here that limit I am reading with the help of n. Okay, ampersand n. Now we are generating the series here with the help of this for loop for I equal to 0, I less than n, I plus plus. Okay, we are calling the function Fibonacci, which returns the value for each I value, which is going to be printed immediately with the help of this particular print function with an offset of 3D or 4D. Okay, I'm giving 3D here, calling the function here for all such I. Okay, so let us try to execute this. I hope now all of you could have understood this, right? What I'm doing here is in main function, I'm first reading the limit to generate the Fibonacci series, and then for all such I values from 0 till limit, I'm calling this Fibonacci function is designed. So let us try to execute it first. If you want to generate till let us say 50, so it gives me the values. Okay, let us check what went wrong with it. Fibonacci 5 here. Oh, sorry. Here, this is the mistake. The hash include has to be before Fibonacci, right? So, okay, let us try to uh, open another one. Create new project. Mistake was Control V. This statement before, right? Control V. Now let us try to execute this again. Let us give value as 50 here. Let's see what went wrong. Let me just check first here. Yes. Let us take this else, otherwise doesn't matter actually whether it else or simple if also no issue. So it has stuck up I think somewhere all in some loop I think probably. Why it's taking so many inputs here? Only one input has to take, right? Listen. Some problem happening. Let's close it. Let us leave this program again. Go for a new one. Let's see what happened actually wrong in the program. We will see intent n equal to 0, return 1. You can write else if I can have else statement here otherwise. Else if, yeah, simple else I can say. Okay. If n equal to 0, return 0. Else if n equal to 1, return 1. Else I say return of Fibonacci of n minus 1 plus n minus 2. Okay, so this whole together as a single statement. So we put this in a parenthesis. Now let us try to again execute and see. Let us generate for 20. Yes, you can see the value. 20 values are being generated here. Okay, till 20 in the sense 20 times this is going to be repeated, right? So for all 20 values, this is for 0, this is for 1, this is for 2, fib 3, fib 4, 5, fib 6, 7, 8, 9, 10, and then more than 10 actually there is some issue you are getting, right? Okay. We'll execute it for simple 10 and then see 10 I have given. So for 10 this is how the result is. Good. So 10 we don't have an issue. If you're giving more, maybe the compiler is not taking the output to the maximum. We can execute this in the Linux and see otherwise. Okay, we'll do one thing. I'm opening Linux terminal here. Is all of you able to see my screen? Yes. Yes, please let me know if are you able to see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
I will. I'm opening here Linux. I have Ubuntu, which is Linux version. Anyone is having Linux at home? Those are having Linux at home, they can practice in Linux. Yes, all of you, I think, I hope you can see my screen. Yes, in my terminal, I'm opening the file here. PI Fibonacci series, I'm saying here. Fibonacci using recursion, right? So REC, I'm saying Fibonacci REC dot C. Fibonacci REC dot C. Now I have to first enter into the insert mode, right? And then I have to use this entire, I have copy pasted the one which I've written before. Yes. Yes. So you can see here, let us try to execute this program now. Escape shift colon WQ, right and quit, and we'll compile this first. You see, Fibonacci REC dot C. Okay. So there are no errors. I can now go for execution. Dot slash a dot out here. I can give a value, let us say 20. If I'm giving, it has to generate. You can see it is generating the values. Yes. If I give 10, it is giving, yeah, 10. Fibonacci 0, Fibonacci 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this is how it's going to generate the values, right? I hope this is clear to all of you. Fibonacci series. Yes. So we'll close here for now. We'll continue the same in the next class.